Hello everyone, I am Dr. P. Kumari, working as Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering. Today I want to discuss about the topic line integral. So what is the line integral? What is the formula for that? How we can calculate the line integral? And what are the problems we can calculate by using this line integral? I am going to discuss now. So we will go to the definition. See here, a line integral is an integral where the function to be integrated along a curve. So here a line integral is an integral where the function to be integrated along the curve. So we can integrate the function along the curve. So one point to other point. We can see here one curve is here. So we have to calculate this line integral along this curve from one point to another point. So we will define the function. After that, we can calculate or we can integrate the given function along the curve. That is called line integral. This function to be integrated may be scalar field or a vector field. Here we have to define the function, or there may be a given function. That function may be scalar or vector field. It may be a scalar field or it may be a vector field. And line integrals are necessary to express the work done along a path by a force. So here line integrals are necessary. So where it necessary to express the work done. So what is the work done along the path by a force. And here line integrals are needed to describe circulation of fluids. So here we can use for the work done also. So they will give the problems based on the work done, and here based on the circulation of fluids also. Here also line integrals are needed. So in the work done also and circulation of fluids also. And they are also important in describing the relationship between electric and magnetic fields. Here, these line integrals are important where to describe or in describing the relationship between electric and magnetic field also. So here we can observe, we can use the line integral for the work done and circulation of fluids and to find out the relation between the electric and magnetic field. So the concept of line integral is a natural generalization. So what is that natural generalization of the concept of a definite integral? What is the definite integral? Integral a to b f of x dx. Here, this is nothing but a generalization of concept of definite integral. So definite integral is nothing but integral a to b f of x dx, where the integral f of x exists for all x in the interval a comma b. So here we can observe one figure. So here we need to integrate the line integral along this curve. So we can observe the point from starting here. So we have to define the function according to the given data. After that, we can do this line integral. This is nothing but based on the generalization of definite integral. So line integral of a scalar field. So what is the line integral of a scalar field here? The line integral of a scalar field. So before just now we discussed that line integral, to calculate the line integral, that function may be a scalar or may be a vector field. If it is scalar field, so then we can say that this is equal to f of r over a curve. Why we are taking over a curve? So here we need to calculate the line integral along a curve only. So that we have to define this will be over a curve. So by subdividing the curve into small scalar elements of length ds. Why we need to subdivide the curve means here we can observe in the figure. So in this figure, so these limit values, this starting value and ending values may be different. So we can't calculate from starting to ending point along the same values. That's why, so from here to here, what are the starting value, what are the ending value, like that. So based on that, we have to subdivide the given curve. So given curve into small scalar elements that with length ds, and multiplying each with ds by the average value of f on the element, and after that summing all elements. That means we are integrating, we are subdividing the given curve as a small values or small elements. After that we are integrating from one end to another end. That is nothing but line integral of the scalar field. We can observe the formula here. We can write that one as integral over c. Why we are taking here over a curve c, over a curve c, f of r ds. So here f of r is scalar here. So we are multiplying with the ds, that is the length. So we are summing the all elements over the c. So starting from one value to another value along the curve. So line integral of a vector field. If it is vector field, how to define, what is the function, we can see here. Let f of r be a vector field. Let f of r be a vector field. C is a directed curve and dr is the infinitesimal displacement vector along C. Along C. C is nothing but curve. Here we are taking f of r is a vector field and C is the directed curve and dr is the infinitesimal displacement vector along where, along curve C. So then the line integral of f along C is defined as integral over C. Here f of r is the vector field dot d. Let the curve is parametrized. So before the curve is general curve we are taking here. If it is parametrized, then the function will take r equal to r of t as t goes from a to b. Here we are taking that parameter, that is r equal to r of t for that curve, and t goes from a to b. Then that integral becomes, we can observe here, integral over f of r dr equal to, here t is from a to b. So integral a to b. And the function is f of r, but here r is in terms of t. So f of r of t. And here dr is there, we are going to multiply with dt. So dr by dt into dt. So we can write this one as a r dash of t. R dash of t is nothing but dr by dt. So derivative of r. So in place of that we are writing r dash of t into dt. So here integral over c f of r, integral over c f of r dr is equal to integral. So here we are taking t is limits from a to b. So we are taking a to b and f of r, actually f of r is there here. R is here r of t. So in place of r we are replacing r of t. And in place of dr, here they do parameterize it here. So we have to write dr. We are multiplying and dividing with dt here. So then there is no change in the value. So now this is dr by dt into dt. So integral a to b f of r of t. So here this value dr by dt value I can write it as r dash of t. So here r dash of t equal to dr by dt into dt. This is the form. So if it is the curve is parameterized, then r equal to r of t, then we can write integral over f of r dr equal to integral a to b f of r of t, r dash of t into dt. Now Just now we discussed in the first slide, we are going to calculate work done and circulation of the fluids and relation between the magnetic field and electric field by using the line integral, right? So what is the formula for that work done by force? We can observe here. If F represents the force acting on a particle moving along an arc AB. Here, F represents the force acting on a particle moving along arc AB. Then, total work done. So, we are indicating here work done with W. So, total work done by F. So, how we can define the total work done by F? And given by the line integral is W equal to, here arc is from A to B, right? So we are taking A to B and F dot df. That is only we are already know integral over C F dot dr bar. So here that curve is arc, that arc is A to B. That's why we are writing integral A to B F dot dr. This is the formula for the work done. This is the formula for the work done by a force. Next, coming to the circulation, we can observe here, if U bar represents velocity of a fluid, U bar represents velocity of a fluid fluid particle, and C is the closed curve. C is the closed curve. Closed curve means there is no open. So, starting point is A and ending point also A. So, here V is and at A. This is the closed curve. So, here UR represents the velocity of a fluid particle. And so, integral over C. This V bar is nothing but M. So, we are taking here velocity. So, V bar dot dr bar. This is called circulation of V bar around the curve C. Around the curve. So, what is the curve? We are taking that closed curve, right? So, that's why we are taking the around the curve C. Now, if integral over C, V bar dot dr bar is 0. If we calculated the circulation of the V bar, if that value is 0, then we can say that V bar is conservative. If it is 0, we can say that V bar is conservative. This is the very important definition you should remember, because in some of the problems directly they will give V bar is the conservative. So what is the meaning of the conservative? So integral over C, V bar dot dr bar is 0. Then we can say that that is the conservative. So then we can use this form. So that's why we have to remember and we have to learn these basic points or node points to calculate the problem easily, because in some of the problems they will not give the form like this. Directly they will give that vector field is conservative. So what is the meaning of the conservative? We have to remember like this. V bar dot dr bar equal to 0. Then we can say that the V bar is the conservative. Is it clear? So no work done and energy is conservative. Here no work done and energy is, because here we are getting that dot product value is 0. That means there is no work done. So bad. The energy is conservative. And here, if the circulation V bar around every closed curve C in the region D vanishes. So in the closed curve, every point this circulation will be 0, because it is the, if it is vanishes, then we can say that that one is irrotational in T. That reason is vanishes, then it is irrotational in T. So these are the node points we should remember. So we can use these basic points or node points in the problems in the middle of the problem also. Here one more definition, same for the work done by force. If F bar represents, we can define like this also. If F bar represents the force vector along acting on a particle moving along an arc AB, then work done during a small displacement dr. So that is what F bar dot delta R. Hence, total work done by F bar, we are taking the displacement from A to B, from point A to B. So given by that point, starting point A to B and F bar dot dr bar. This is the formula for the work done. If they're asking to calculate the work done, so that means we have to calculate integral over A to B F bar dot dr bar. If the force F bar is conservative means, if it is conservative means that F bar dot dr bar is 0. Then there exists some scalar there is some scalar potential that is pi. So we can say that F bar equal to del pi. F bar equal to del pi. This is the one more definition and one more note point you have to remember here. Before it is conservative, we can know that integral value is 0. And here the work done and that F bar is conservative, then there exists a scalar potential. What is that scalar potential? Pi. So F bar equal to del pi. F bar equal to del pi. So curl F bar equal to, so F bar already we defined here for the scalar potential, that is del pi. So curl of del pi, in place of F we are replacing del pi. So curl of del pi equal to 0 bar. So is called scalar potential. This is called scalar potential. So here these 3 points you should remember to calculate the work done, to calculate the conservative, to calculate the curl F, if it is 0, to calculate the scalar potential. So many different problems are there by using these definitions and note points. See the problem. Given if F bar equal to 3xy into I minus y square j. So here the given F bar equal to 3xy into I minus y square j. Here what we have to calculate? Here they are asking to evaluate integral over C F bar dot dr bar. What we have to calculate here? Integral over C F bar dot dr bar. Where C is the curve. What is that curve? They are giving the curve is given here y equal to 2x square. The given curve is y equal to 2x square. And that curve is from 0, 0 to 1, 2. 0, 0 to 1, 2. Here they given the function. This is vector field. We have to evaluate the integral over C F bar dot dr bar over the curve. What is that curve? Curve is given y equal to 2x square. That is the curve is from 0, 0 to 1, 2. This is the given data. So first we have to write the given data. So we can observe here. What is the given data here? F equal to 3xy into I minus y square into j. And they given the curve also. So curve is y equal to 2x square. What is that curve? Curve from 0, 0 to 1, 2. The curve is from 0, 0 to 1, 2. So now here I can calculate the integral by using the dx or dy, any one. So that's why first I am differentiating this y equal to 2x square. So dy equal to 2 is the constant and x square is 2x into dx. So finally dy value is equal to 4x into dx. That is only 0 here. Dy value is 4x into dx. So now I am going to calculate integral over C F bar dot dr bar. So integral over C F bar dot dr bar. So here integral over C. What is the F value? F value they given here 3xy into I minus y square into j dot F bar dot dr bar. So what is the dr bar? Dr bar is nothing but dxi plus dyj. So this is the dr bar you have to remember. So here they will not give this dr bar. We have to remember if they given 3 components we have to write with the 3 components. If they given 2 components we have to write with the 2 So dr bar equal to dx into I bar plus dy into j bar. So here f bar dot dr bar. So here we are going to do the dot product. What is f bar dot dr bar here? So 3xy. I component here 3xy, here 3x. So 3xy into dx. I dot I is 1 plus. Here now y component. So y square minus y square into dy. Finally this is 3xy dx minus y square dy. What is the f bar dot dr bar value? 3xy dx minus y square dy. So that is only we can observe here 3xy dx minus y square into dy. So now we can see the next one, how to integrate this function. How to integrate this function. So here the curve is from 0, 0 to 1, 2. The curve is from 0, 0 to 1, 2. So here we can take these are the x and y points. So x is from 0 to 1 and y is from 0 to 2. So what are the values we are having here? X is from 0 to 1 and y is from 0 to 2. X is from 0 to 1 and y is from 0 to 2. So now here we are converting all terms, this dx dy term in terms of x. So that's why I am writing the x limits. I am writing the x limits here. So x limits are 0 to 1, 0 to 1. Here 3x. After that, in place of y equal to 2x square, they given in the curve, right? I am replacing y equal to 2x square dx minus y square. Y square means 2x whole square. So 4x power 4. What is the dy value? 4x into dx. 4x into dx. We can observe here how we can get this. So here integral over c 3xy dx minus y square dy. 3xy dx minus y square. Now I need the limits to calculate over the curve C. So here I have the points from 0, 0 to 1, 2. So this is the x value, this is the y value, and this is the x value, this is the y value. So x limits are 0 to 1. X limits are 0 to 1. And y limits are 0 to 2. Y limits are 0 to 2. I can take x limits or y limits along the curve based on the problem. Sometimes we can use x limits, sometimes we can use y limits. Here y equal to 2x square curve is there. So that means I can write here dy equal to 4x into dx. Now here I am going to convert dy as a dx. That means I need the x limits. That's why I am writing here 0 to 1. In place of y, we need to convert in place of y and in place of y square and in place of dy, I need to replace the values in terms of x. So y equal to 2x square. So here in place of y, I wrote 2x square and y square I need, that is 2x square whole square. This is 4x power 2. 4x power 2. So in place of y square, we wrote 4x power 4. Now I need dy. So dy I have already calculated 4x dx. So in place of dy, I wrote 4x dx. Now I got the limits for the x. So I wrote x equal to 0 to 1. Now I am simplifying this. Now, so integral 0 to 1 3x into 2x square dx minus 4x power 4 into 4x dx. Now integral 0 to 1, 3 2s are 6. X into x square is x cube dx minus here 4 into 4 is 16. X power 4 into x power 5 is x power 4 into x is x power into dx. Now I can integrate separately. So 6 is the value constant. I can take it out. So integral x cube dx, integral x cube dx 0 to 1 minus 16 is the constant, taking out integral 0 to 1 x power 5 into dx. Now 6 into integral x cube is x power 4 by 4 and limits are 0 to 1 minus 16 into integral x power 5 is x power 6 by 6, limits are 0 to 1. So these are 6 x power 4 0 to 1 minus 16 x power 6 by 6 0 to 1. Now we are replacing the limits here, 6 by 4. So 1 power 4 minus 0 minus 16 in by 6 into 1 power 6 minus 0. Finally, this value is 6 by 4 minus 16 by 6. So when you are simplifying this, we got this one 6 by 4 is nothing but 3 by 2. So 16 by 6 is nothing but 8 by 3. So finally, when you are simplifying this 3 by 2 minus 8 by 3, this is equal to 6. LCM is 6. So 3 3s are 9 minus 8 2s are 16. So 9 minus 16 is minus 7 by 6. This is our final answer. This is the value of integral over C f bar dot dr bar. Integral over C f bar dot dr bar. So this is the way we can calculate the line integral along the curve based on the given points. So first of all, we can know what is the curve they given. So how we can calculate and what is the dot product and what are the dy value or dx value based on the given problem. These all basic points are all given data. You should analyze first. After then we can calculate like this to get the answer. Is it clear? See the next one. If f bar is equal to x square minus 27 into I minus 6yz into j plus 8x z square into k. So here we are going to calculate integral f bar dot dr bar from the points 0, 0, 0 to 1, 1, 1 along the straight line. So what is that straight line? From 0, 0, 0 to 1, 0, 1 and 1, 0, 0 to 1, 1, 0 and 1, 1, 0 triple. So they given 3 type points here. So 3 breakdowns are there. So first of all, what is the given data we are having? Given f bar equal to x square minus 27 into I minus 6yz into g plus 8x square into k. So here I should know about to calculate the integral f bar dot dr bar. What is the dr bar? I should know, right? So dr bar equal to dxi plus dyj. Actually, if they given two components, then I can calculate this dx and dy. Here, if it is three components, we have to write dz also, dz into k. So now first I am calculating what is the f bar dot dr bar. So here f bar dot dr bar equal to f bar is x square minus 27 into I minus 6yz into j plus 8xz square into k dot dxi plus dyj plus dzk. Now I am going to do the dot product here. I quotient and here also I quotient x square minus 27 into dx. I into I is 1. Next plus here j quotient is minus 6yz into dy and j dot j is 1. Next plus 8xz square into dz k dot k is 1. So this is the final value of integral f bar dot dr. That is only we can see here. Now we are going to integrate along that curve. We can observe first what is the straight line they given first from 0, 0 to 1, 1, 1. We can observe here. So here along the straight line, what is the line we are taking from First 0, comma 0 to 1, comma 0, comma 0. So here x, y, z. Here is x, y, z. Here y value is 0 to 0 and z value also 0 to 0. And what we are getting here, y equal to 0 and z equal to 0. And here x value is only 0 to 1. X is 0 to 1. So that is only we can calculate. So x changes from 0 to 1. So that one, here the point is O to A we are taking. So along OA we are writing. So along OA, f bar dot dr bar, already we calculated f bar dot dr bar, we are going to write here. So here that f bar dot dr bar value is equal to x square minus 27 into dx plus next one is minus 6yz into dy. Minus 6yz into dy. Next one is plus 8x z square into dz plus 8x z square into dz. So already y is 0, z is 0. That means dy equal to 0 and dz equal to 0. So this is also 0, this is also 0. So now these two terms are 0. Only you will get the term f bar dot dr bar is equal to x square minus 27. X square minus 27. That is only we are writing here. So integral 0 to 1 x square minus 27 into dx. Now we are going to do the integration. So x limits are 0 to 1. So individual integration we can do here. So integral x square dx minus 27 integral dx. This is 0 to 1 and 0 to 1. So x square is x cube by 3 minus integral dx is x. So limits are 0 to 1. So after replacing the limits, so 1 by 3 minus 0 minus 27. So finally we got here minus 80 by 3. This is the first straight line. This is the first straight line. Now second one. Now along 1 comma 0 comma along AB. So 1 comma 0 comma 0 to 1 comma 0. Here x value, here also x value. X is from 1 to 1. Okay. X is from 1 to 1. That means x value is 1. And here y value is 0 to 1. So y value is 0 to 1. Y value is 0 to 1. And z is 0. Z is 0. Z is 0. So along that here x equal to 1, z equal to 0. That means dx equal to 0 and dz equal to 0. Why dx equal to 0? X is the constant, means derivative of that value is 0. So that's why x equal to 0, z equal to 0. So dx dz is 0. Only y is changing. Y is changing from 0 to 1. So now we are doing along y. So in that f bar dot dr bar, we are replacing dx value and dz value, both are 0. Only we are getting here integral 0 to 1 minus 6yz into dy. So now we are integrating this value. So minus 6 is the constant taking out. Here what is the z? Already we got the z value is 0. And here if it is z, what is the final value? So we are replacing the z value is 0. So finally this is 0. This integral value is 0. So integral along AB is 0. Now one more straight line is there we are going to calculate now. Now along the straight line BC. Now 1 comma 1 comma 1 1 comma 1 comma 0 to 1. So here x equal to 1, there is no change. Next y equal to 1, there is no change. That means dx equal to 0 and dy equal to 0. Next z is changes from 0 to 1. That means we are going to do along the z now. So integral BC f bar dot dr bar is only z terms will get, that is integral 0 to 1 8x z square dz. So here z value how much here 0 to 1 and what is the x value? X value is 1. Integral 0 to 1 8 into x value is 1 and z square into dz. Now here 8 is the constant taking out. Integral z square is z cube by 3. Integral z square is z cube by 3. Limits are 0 to 1. Now it is 8 into 1 by 3. Finally this value is 8. This value is 8 by 3. So now I am going to finalize the integral over C f bar dot dr bar. So integral over C f bar dot dr bar equal to, first I calculated along OA f bar dot dr bar plus along AB f bar dot dr bar. Next plus integral BC f bar dot dr bar. What is the along OA value? Minus 80 by 3. So minus 80 by 3 plus along AB value. What is the along AB value? That is 0. So along AB value is 0. Plus along BC value is 8 by 3. So here minus 80 by 3 plus 8 by 3. So finally here 3. So minus 80 and here this is plus 8. So here before this is when you are doing the curve, that value is so finally we are simplifying that we got. So this is minus 80 by 3 plus 8 by 3. So nothing but minus 80 plus 8 by 3, nothing but this value is 72 by minus 80. So final answer is like. So we have to observe and we have to calculate the answer carefully. So this is the way to calculate the line integral along the curve if they given two curves like this. So here OA and here AB, here BC. So we have to calculate three curves. After then we can add to get the final along the curve from O to C. So we can calculate this type of problems like this. So is it clear how to calculate the line integral? It's very easy. We have to remember the basic points to calculate that value. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.